Hello everyone, we're going to talk about section 5.1 today, which is about simple interest and discount. So now we're on to chapter 5, which is going to be more about the basic financial and business mathematics. So starting here with our simple interest and discount section, we're just going to talk a lot about what interest is and discount and talk a lot about the terminology used in financial math. So first of all, we have interest, which is the fee paid to use someone else's money. So it's how you gain interest on loans. So you'll owe a certain percentage for every year on a certain amount of money. Then we have our simple interest, which is the interest calculated on loans of 1 year or less. So you'll only pay this on the amount borrowed or invested and not on your past interest. So a lot of the simple interest problems that we'll have, it'll be like, oh, we owe this much amount of money for this amount of time, which was a year or less. So when we calculate our simple interest, we're just using that first initial period of when we borrowed that money. Because if we went on further for a year, we'd have to calculate the interest on that first year and then calculate our interest again since it's accumulating. Then we have the amount borrowed or deposited is what we call the principal. So the principal is what we'll say is the amount. If you borrowed maybe $5,000 from the bank, your principal will be $5,000. So it's the amount that you invested or you borrowed. So it's that initial amount. Then we have the rate of interest is given as a percent per year and is exposed at, expressed, not exposed, I don't know why that's written there. Let's fix that real quick. So we have expressed. There you go, not exposed, expressed as a decimal. So an example, if we had 6%, this would be 0.06, or 11% would be 0.11. So we're just turning these percentages into decimals. Then we have the time during which money is accruing interest is calculated in years. So every time we do any sort of time, it's always going to be in years. So if we say, well, for 9 months, we want that in terms of years. So 9 months would be, well, 1 year is 12 months, so 9 months, that'll be 9 out of 12, so that'll be 3/4 of a year. So whenever we calculate time, it's always in terms of years. Then we have our simple interest is the product of the principal, the rate, and the time, which if we think about our simple interest, which is just the amount we invested and the rate at which our interest accrues, and however long of time, less than a year, that we're thinking about, that's how we calculate our simple interest. Since there's no other factor of interest that has already been accrued or anything like that, that's why it's called our simple interest. So it's just the product of those three things. So here's our official definition of our simple interest. So we have the simple interest I, which we'll always call our interest I, on P dollars, so our principal, at a rate of interest R, so R is our rate of interest, per year for T amount of years. So that's going to be I is equal to PRT. That's a very important equation that we're going to have to remember going through our questions here. So for example 1, we just want to find the simple interest for each loan. So we're utilizing this I is equal to PRT. So starting with problem A here, all we want to do is find our simple interest. And for A, we have that we invested or borrowed $2,000 at 8.5% interest for 10 months. And so we know our equation is I is equal to PRT, and we're trying to find I. So we can say here, since we know our equation is I equal to PRT, and we want to find I, we know our principal is going to be 2,000. So we'll say 2,000. Right here we say P is 2,000. R, or our rate, is 8.5%, which we know we have to put this in decimals, so we know that R is going to be 0.085. Then our time, since we're doing for 10 months, and our time is always in years, we'll say is 10 divided by 12, which we know is also just 5 divided by 6. All right, so now we can plug all these things in to find our interest. So we have I is equal to PRT, so we already have our principal, or our initial value, which was $2,000, times our rate, which is 0.085, times t, time, which in our case is going to be 5/6. So let's just calculate that 5/6 here. So we have 2,000, 0.085. If you calculate 5 divided by 6, we'll get 0.833. Now I invite you to take a moment, use a calculator to calculate your value of your interest. So if you've calculated it, you should get that your interest is equal to $141.61. So this tells us that if we invest or borrow $2,000 with a rate of interest at 8.5%, after 12 months, we would have accrued $141.61 in interest. So this just tells us how much interest that we've accrued. So let's say at the end of 10 months, if we wanted to pay this back or take our investment out, we would have a total of $2,141.61. So that's just kind of how you accrue that interest. All right, now for part B here, we're going to do $3,500 at 10.5% for 1.5 years. So we know that our simple interest rate is supposed to be for a year or less, and in this case, we're doing 1.5 years. This is checkpoint 1 in your book. So you can always go back and look there. All right, so we want to set up our values here. So we have our principal, which is going to be $3,500. Our rate, which is going to be 0.105, since we're just moving that decimal point 2 spots to the left. And then our time, which is just going to be 1.5. All right, so now we have all of our values. We know our equation is I is equal to PRT. And now we just want to plug everything in. So we get I is equal to our principal value of 3,500 times our rate, which is 0.105, and our time, which is 1.5. So I invite you again to take a moment, calculate this on your own. And if you do, you should get $551.25. So this means that if you invest or borrow $3,500 and it has an interest rate 10.5%, and let's say you do this for 1.5 years, you know that at the end of 1.5 years you'll have $551.25 in interest. So you'll just add that on to your original amount if you want to find the total amount that you now owe or can take out. All right, so now we see an exception to simple interest would be called a corporate bond, or similarly a financial investment. And this pays simple interest twice a year for a length of time. At the end of that time, your bond will mature. So the company returns your initial investment to you at maturity. So that means that however much that you have accrued with your interest, when you get your initial investment back, you get it at maturity. So you get however much interest you have accrued on that value. And that is kind of how corporate bonds work. So let's see example 2 here. We want to find the semi-annual interest payment and the total interest earned over the life of the end of the corporate bond. And so our corporate bond here that we're doing is going to be $9,000 from Barrick Gold Corp at a 10-year bond at 3.85% interest. So if we want to do semi-annual just means twice a year. This means that we want to use our original equation, I equals PRT. So let's identify all of our values here. We have P, which is 9,000. our rate, which is going to be 3.85%, so we're going to say 0.0385. And our time, since we're thinking about semi-annual, we're going to scoot that value over there. So our time, semi-annual means twice a year, so basically half a year. We're going to say 0.5. All right, so now all we have to do is plug this into our equation. I equals PRT. So we're going to see I is equal to 9,000 times 0.0385 times 0.5. So now you can take a moment to calculate this on your own. And if you do, you'll see that semi-annually, the interest that grows on this bond will be $173.25. So that means that twice a year, you will get that value added onto your investment. All right, so now we see part B, which we want to see over 10 years. So since we're using our simple interest equation, our corporate bond, since this is its one exception, we calculate our simple interest the exact same way, and now for time, we're saying 10 years. So if we write this, our principal stays the same at $9,000, so does our rate, 0.0385, and now our time is 10. So we'll calculate this the same way, and we get that our interest is equal to principal, which is 9,000, our rate at 0.0385 times our time, which is 10. So if you calculate this on your own, you'll see that after 10 years, you would have gained $3,465 in interest. So if you invested $9,000 and it's a 10-year bond, at the end of 10 years, you'll get your initial investment, $9,000, plus your matured interest, which is $3,465,000. So in total, you would end up getting $12,465 at the end of 10 years. So you see that with our corporate bonds, we can still use our simple interest rates, but now when we do it, we see that we gain all of the money at the end of its maturity. All right, so now we can talk about future value. All right, so future value. If you deposit P dollars at a simple interest rate R for T years, then the future value or the maturity value A of the investment is the sum of the principal and the interest it has earned I. So we have our definition here of our future value or maturity value, you can call it whatever you'd like. For our simple interest, we have here that our future value A, so we'll call future value or maturity value A of P dollars, still we're using P as our principal, T for our time in years, and R for our rate. All we see is that we get the equation A is equal to P plus I, or if you do not end up finding I and you just want to calculate it all straight out, we get A is equal to P times 1 plus RT. So now let's work with example 3. So we want to find the future value of each one of these borrows or investments. So for part A, we have 1,000 at 4.6% for 6 months. So we want to use our equation here, and we know that P is equal to 1,000. Our rate is 0.046. And our time is 6 months, so it's half a year, so we'll use 0.5. And we're going to scooch these over. I really wrote them very close together for the last few sections. All right, so we have T is equal to 0.5, so half a year. And our equation is going to be A is equal to P times 1 plus RT. So when we calculate this, we'll get A is equal to 1,000 times 1 plus 0.046 times 0.5. All right, so if you calculate what we have in the parentheses, we'll end up seeing that we get 1,000 times 1.023. Multiplying that value by 1,000, we see that we get $1,023. So I know that that is how much our investment has matured in the 6 months. So it's gained $23 of interest. Moving on to Part B, we have $8,970 at 11% for 9 months. So our principal value is $8,970. Our rate, since it's 11%, is going to be 0.11. And our time, which is 9 divided by 12, so 9 months out of 12. Exclude that for again. Is going to be the same thing as saying 3 divided by 4, or 0.75, since we know that 3 divided by 4 is 75%. All right, so now we have all of our terms here. We want to use our equation A is equal to P times 1 plus RT. If you would like to use the equation A equals P plus I, you can feel free to calculate the interest and then add it onto your principal. But this way, it's just one equation and it goes a lot faster. So now we get A is equal to our principal value, or 8,970, times 1 plus 0.11 times 0.75. So you can feel free to calculate that. This time we're just going to calculate the future values straight from this equation. And if you did that, you should have gotten $9,710.03. So this is how much our investment is worth after 9 months, 11% interest. And lastly, for Part C, we're going to see $95,106 at an interest rate of 9.8% for 76 days. So now we're thinking in terms of days instead of months. So we're going to do the same thing as we did before. We have a principal, which is 95,106. Our rate, which is going to be 0.98. And our time is going to be 76 divided by 365. Since we now are thinking about days, there's 365 days in a year. So we take 76 divided by 365. All right, so now we're going to use the same equation as before, where we have A, or our future value, is equal to our principal times 1 plus our rate times our time. So we get 95,106 times 1 plus, I missed a 0 here. Our rate should be 0.098, not 0.98, because that would be 98%, and that would be a lot. So we have 0.098. And our time, which is going to be 76 divided by 365. So now we're just going to calculate A, or our future value, straight through. So I invite you to take a moment and maybe calculate this on your own. You can pause the video if you would like. And we see that an investment of $95,106 with a interest rate of 9.8% for 76 days will earn us the value of $97,046.68. cents. So now we know that's how much it would accrue after just 76 days. All right, so now moving on from future value, we have present value. So a present value would be a sum of money that could be deposited today to yield some larger amount in the future. It's called the present value of that future amount. And we know that the present value refers to the principal to be invested or loaned, so we use the same variable p in our equations as we did for the principal. So now our present value is also the same variable as our principal, since our principal and our present value is now going to mean about the same thing in the context of these questions and these equations. And we get that the formula for present value P of a future amount of A dollars at a simple interest rate R for T years is going to be P is equal to A divided by 1 plus RT. And if you hadn't noticed by now, you see that a lot of these equations are just manipulations of the former equation. So we see that our present value now is just a manipulation of our future values here. So we also see that in interest problems, P always represents the amount at the beginning of the period, and A will always represent the amount at the end of the period. So knowing these values, it's easier to think about principal and present value as just the amount at the beginning of the period, or your initial amount, and A is just always the amount at the end. So we're going to move on to example 4, which is also checkpoint 7 in your book. We see a firm accepts a $21,000 note due in 8 months with an interest of 10.5%. 2 months before it's due, the firm sells the note to a broker. If the broker wants a 12.5% return on his investment, how much should he pay for the note? So, first thing we want to do is that we want to find the future value of our loan. Since we know that our loan is due in 8 months at a certain amount of interest, we want to find how much it's going to be worth at the end of that time. So we need to find that future value first before we can go back and find our present value. So if we want to find our future value, we know that equation is just going to be A is equal to P times 1 plus RT. We know our principal value, or our initial value, is 21,000. Our rate is 10.5%, so 0.105. And our time is just going to be 8 months, or 8 divided by 12, which is the same thing as saying 2 divided by 3. So to calculate our future value here, we're going to get A is equal to 21,000 times 1 plus 0.105 times 2/3. All right, so take a moment to calculate that on your own. And if you had, you should have gotten $22,470. So we know that this investment at the end of 8 months is going to be worth $22,470. But we're saying that 2 months before it's due, the firm is going to sell the note to a broker, and the broker wants a 12.5% return on the investment. So we're thinking about how much should he pay for the note. So we know if we stopped 2 months short, so it's been now, we're thinking that it's been 6 months, and we know that in 2 months, the bank will receive the full amount of $22,470. Since the bank wants a 12.5% return, we can compute the present value for this amount at 12.5% for 2 months. So now essentially what we're doing is that we are calculating the present value to see what our loan is going to be worth after 2 months at 12.5% return. So we'll use our equation of present value, which was P is equal to A divided by 1 plus RT. And we now use our principal value is going to be that 22,470. Our rate now is 12.5% or 0.125. And our time is now 2 divided by 12 or 1 divided by 6. All right, so now we can put all these values together. Our future value, not our principal or our present value, because that's what we're trying to find. Our future value was $22,470. And now we want to plug this into our equation. So we have P is equal to A divided by 1 plus RT. It's going to give us P is equal to $22,470 divided by 1 plus our rate, which is 0.125, times our time, which is going to be 1/6. So I invite you to pause the video and calculate this value on your own. And if you had, we see that our present value should be $22,011.43. So if our broker wants a 12.5% return on the investment, he should pay $22,011.43 for the note, because that would have been the present value at 6 months. All right, so now we can move on to thinking about discount. So in the cases that we've worked with, we see that the borrower receives the principal, but it also pays back the principal plus interest. So in the case that you're borrowing money, if you're borrowing money from a bank and they charge you interest on a value, when you pay all that back, you have to also pay the interest. So you're not just paying back your initial amount. In a simple discount loan, however, the interest is deducted in advance from the amount of the loan and the balance is given to the borrower. So what we're seeing here is that the borrower receives the principal without the interest, but pays back the principal as well. So a common example of simple discount loans are the U.S. Treasury bills, or they're called T-bills, which are short-term loans to the U.S. government by investors. These T-bills are sold at a discount from the face value, and the Treasury pays back the face value at maturity. So we're going to put this into practice here with our example 5, which is going to be numbers 31 and 32 from your book. So this is the finance problem. So we have historically, Treasury bills offered at higher rates. Are offered at higher rates. On March 9th, 2007, the discount rates were substantially higher than in April of 2013. For the following Treasury bills bought in 2007, find A, the price of the T-bill, and B, the actual interest rate paid by the Treasury. So We're going to do 2 parts for each of these. In this case, you see that I actually labeled them 31 and 32 since we're doing parts A and B, so I didn't want it to be like A, B, B, B. So 31 and then 32, parts A and B. So, and for now, I'm just going to scoot this over to give us a little bit more room. So for 31, we see we have a 3-month, $20,000 T-bill with a discount rate of 4.96%. So for part A, we want to find the price of our T-bill. So our discount rate, we're just going to use our simple interest rate to find our discount. So, or to start this problem, we're going to use our simple interest rate. We'll say that discount is equal to PRT. So we have here that our principal is 20,000. Our rate is 4.96 or 0.0496. And our time is 3 months out of 12, which that is going to be equal to 1/4, or as we know, 0.25. All right, so discount, which I'm just going to rewrite as D, is equal to our principal, 20,000, times our rate, 0.0496, times our time, which is 0.25. So I invite you to take a moment and calculate this on your own. And you'll see that the discount is going to be $248. And this was part A. All right, so we found that the discount value was $248. And now for part B, we want to find the actual interest rate paid by the Treasury. So for part B now, what we're going to do is that, sorry, I went a little bit ahead of myself. So we found our discount rate, but we're trying to find the price of the actual T-bill. So we're one step short of the actual final answer. So the price of our T-bill is going to be the face value minus the discount. So our face value in this case is $20,000. And we're going to subtract our discount, which is 248. And that is going to give us $19,752. So the price of the actual T-bill is $19,752 since we got that simple interest rate taken off, or we got that discount. All right, now we can move on to part B. So part B is we want to know the actual interest rate paid by the Treasury. So we got our discount at 4.96%, but now we want to see what's the actual interest rate that the Treasury paid. So now our new principal is $19,752. So our principal is $19,752. We know our interest now, or our discount, which is the same thing, is $248. And what we're looking for is the rate. So we're going to use our simple interest rate equation in order to find the rate. So our simple interest. So we use the same thing that we've used before with I equals PRT. So now we have values for all these things. So we know that I is 248 is equal to our principal, which is 19,752. Our time, which is the same, it's still 3 months, so it's still 25%, or a quarter. And we're trying to find our rate. So now we have R. So what we're going to do here is that we're going to multiply our 19,752 by our time, which is 0.25, or a quarter. So, 248 is equal to, we want to multiply those values together, which will give us 4,938 times R. Since we're just finding R, we're going to divide each side by 4,938. Now, once again, I invite you to calculate this value on your own. And you should have gotten that R was equal to 0.05 or 5% interest. So we see here that the Treasury gave us a discount rate of 4.96%, but the actual interest rate that was paid by the Treasury was 5%. So it was pretty close, not exactly. All right, so now for 32, we're going to do the same thing again, just different numbers. So we have 1 month at $12,750 T-bill with a discount rate of 5.13%. So we're going to do the same thing as before. Now we have our principal of $12,750. Our rate of 5.13% or 0.0513. And our time, which is 1 month. So we're going to say 1 divided by 12. All right, so now we're going to find our discount, which I'm going to call D. So D is equal to PRT, just like our simple interest. And so we can find the discount and multiplying our principal, 12,750, by our rate, 0.0513, and by our time, 1 divided by 12. I invite you to find this value on your own, so feel free to pause the video. And you should have found that your discount would have been $54.51. So now I want to find the price of the T-bill. So price of T-bill, which we know is face value minus discount. So we're going to do 12,750 minus $54.51. And that will give us that our price of the T-bill would have been $12,695.49. All right, so now we found the price of our T-bill, and for part B, once again, we're going to try and find the interest rate that was paid by the Treasury. So we're going to do the same thing as we did before. So now we have a new principal value, and we have our interest value. So our principal is now $12,695.49. And our interest is $54.51. So we're going to use that equation that we had before with just our simple interest. So I equals PRT. And we'll plug in all of our new values. So we have our interest is $54.51. Our principal value is $12,695.49. And we're going to multiply by our time first. So we have 1 over 12, same amount of time, times our rate. So we're going to multiply our principal times our time. That is going to give us, with our interest still at $54.51, now we have $1,000 $507.96 times our rate. So we're going to divide each side by $1,057.96. 96. And as always, I invite you to do this problem on your own or calculate this on your own. And if you had, you should have gotten that your rate would have been 0.0515 or 5.15%. All right. So that is how we find the details of our T-bills. So we see that how much for part A, how much we would buy the T-bills for, and then for part B, we see that the actual interest rate that is paid by the T-bills. And we should see that these numbers are fairly close together, because that's the goal. They want to make these numbers exact if they can, or at least extremely close together. All right, so that concludes our section 5.1 for today. As always, if you have any questions, feel free to send me an email or drop by my office hours, or you can always put in a question into our anonymous question form. And yeah, so don't hesitate to contact me if you have any questions about the lesson that we learned today, and I will see you virtually later. Bye.